All right, guys, good morning. So let's talk a little bit about friction. Friction is a force that opposes movement. One of the biggest things, notice how I wrote it here in pink or in a different color. It opposes movement because it goes the opposite direction of movement. So if movement goes north, friction is going to go south. It is always going to go the opposite direction of movement. It is force that we see between two objects, okay? Friction is also a contact force because two objects need to be touching each other for friction to act. And this contact force, again, goes opposite direction of movement. It's the reason why right now, as you're sitting in your chair, you're not sliding off, okay? It has grip and it's somewhat holding on to you. The two types of friction that we're going to focus on are sliding friction. And this is a friction that occurs when two objects are sliding past one another or moving, and static friction. This is the friction that occurs between two objects that are not moving. So right now, if you look at my notebook, there is friction on the table that is keeping my notebook from falling off or sliding off. One of the things that I like to do if we were in class is you would do something like this. You would get your textbook or something heavy, pick something heavy at home, get your pinky, and then slightly put your pinky up against it. Now try to maintain your pinky doing the same thing and like in a specific position, and then lightly push it. See what happens to your pinky. Notice as I'm pushing it, my pinky slightly goes back and then the notebook moves. That's what you should see. If you do this very, very slowly and you press only with your pinky should move back and then the notebook moves. Okay. Now what that is that I'm seeing both kinds of friction, sliding and static friction. Once I overcome the static friction, the notebook will move. And so when your pinky goes backwards, you're overcoming the static friction. That's what's making your pinky kind of push back. You have to use more force, right? Remember, force is a push or a pull. So you have to use more force to actually push the notebook off and get it sliding. So initially, the static friction is pretty strong in an object that's just standing still. And once you apply enough force to move it, then we move into sliding friction where you can actually move things. You guys are too young, but a few years ago, before we gave you guys each your Chromebooks, we used to have something called Chromebook carts. And maybe if you were in robotics, you got a chance to push those around. So the Chromebook carts would initially be really, really, really hard to move. Sometimes kids had to apply a lot of force to push the Chromebook cart forward. And then once the Chromebook cart was moving, it was easier to push around down the hallway. Think of you, and that's the picture that I have here. It's the Chromebook cart. There's a student. Normally, the student is trying to push the cart. Now, once the cart is moving, we have sliding friction because the cart's moving. But right before it moves, there's static friction. Okay? And static friction is usually stronger than sliding friction. Now, notice there's a couple of things that I put on here. So we have this person, they're pushing the Chromebook cart, right? The weight of the cart is pushing down. And remember that weight is both mass and gravity. And this is the direction that the person is pushing. Now they are going to push with a lot of force because this Chromebook cart is really, really heavy. This is a direction that either static or sliding friction go. Now, which one is it? Which one are you doing? Are you doing static or are you doing sliding? Well, it depends. If the Chromebook cart hasn't moved yet, it's static. If the Chromebook cart is already moving, then it's sliding. Okay? And then this is something called normal force. And normal force is basically how it's a force that pushes up. It's the reason why gravity is not pulling you so far down into the earth that you're sinking into the earth, if that makes sense. We can do another one here. We can do, if this one doesn't make sense, I'm sure all of you at one point, or maybe you're doing it now since you're home and bored, you decide to reorganize your room, okay? You're gonna move things around in your room. So you have this really long, big, heavy dresser, okay? The dresser with all your clothes in it. You were too lazy to take your clothes out, okay? So the dresser's sitting there and you wanna try and figure out how you can get this dresser and you want to move it to a different position. So how many of you have gotten on the floor in this type of situation and pushed with your legs because it's easier to move there, right? Well, our legs happen to be a little bit stronger than our arms for some people. And so let's say you get on the floor and decide to push with your legs, okay? Now, originally you are going to push, you're going to apply a force moving that way because that's the direction that you want to move this dresser. So this is your applied force. Okay. Now remember, friction goes the opposite direction. Now, right before the dresser moves, we're going to have static friction. Once the dresser is moving, it's sliding friction. So since I drew my applied force going this way, my friction is going to go the opposite direction, okay? Now, let's say you haven't moved the dresser yet, so then this would be static friction. And you know, we can always say like, oh, if the dresser's moving, now it's sliding, right? So this is your applied force. Remember, if I'm drawing all of my forces here, I'm going to add the mass or weight of the dresser. Especially if you left all those clothes in there, it's going to be a pretty heavy dresser. And then don't forget your normal force. Okay, notice how they go opposite direction. Your normal force is the force applied by the ground, and it goes directionally up. Right now, we would have watched a brain pop video on this. I'm going to see if I can get you guys access to those brain pop videos. But this is pretty much all there is to know about friction. Friction goes the opposite direction of movement, and there's two kinds of frictions that we're going to be working on. They don't do the same thing. One is right before it moves. The second one is as it stopped moving.